are opening probably from 20th. So 20th for the first semester, and senior batches will come on I think 5th. So we will definitely encourage them also to be part of such event, because it takes a loads of effort to have such an honorable moment for our country, and later on we should also contribute here. So thank you, Manish, for coming to our campus, giving me the briefs of the total. I sincerely regret for not attending the last event. I definitely wanted to do that. Puneet sir told me so many times, but I suddenly got busy. So hope for the success to you and the team, and welcoming Dr. V. Girish again. Thank you.
Thank you, sir.
Okay, thank you, Manish sir. Gives us immense pleasure to welcome Dr. Girish. He joined ISRO in 2006 and also worked on Chandrayaan and Astrosat. His main research interests are understanding the accretion process in wide draft binaries using high resolution X-ray spectra. He has published around 52 papers in national, international referred journals and around equal number in conference proceedings. He also has written a book in Canada, Tarigala Jivana Chakra, sorry for the pronunciation, Life Cycle of Stars. And presently he is Deputy Director at Science Program Office, responsible for astronomy programs of ISRO and managing AstroSat, India's first mission dedicated for astronomy. Welcome, sir. All up to you, sir. Okay.
Thank you very much, Puneet sir, for that kind introduction. So Manish, shall we start, Manish? Okay, I'm starting my presentation. Please let me know if you see or not, and I'll be like turning off my video to save some bandwidth. Okay. Manish, can you see the window? Okay. To the people who are not aware of what exactly this image is, so all these images, whatever the dots you see, they are not debris or they are not something dust or something. They are all satellites. Okay. So you can clearly see two sets of satellites, one just around the Earth and one little elongated. This elongated corresponds to geosynchronous orbit, and the one which is very close to the Earth is the low Earth orbit, which extends from 500 to some 600 to 700 kilometers, like that. So there are other orbits also where you can see some dense satellite population, but most of them are in these two. So somebody has estimated in the last estimation, it has found that there are close to 50,000 satellites in the space now, and this number is going to go further. Okay, this has nothing to do with the presentation whatever I am going to make, but I just wanted to inform you the kind of satellites which are there and how they are going to affect us, both for astronomy or future launches and other things. Okay, why do we do space exploration? All of you are maybe aware of that the first science can be attributed to astronomy, because as soon as the caveman came out of the caves, the first thing he noticed in the night is the twinkling stars, some light specks in the sky, which will vanish during the daytime. They wanted to know what these are and how they come, how they give the light, etc. And are they stationary? They move, all these things. So that his curiosity to know the matter, what is happening, has led to discovery of several discoveries. And now we know that the stars are not the only objects in the sky. There are many other objects like galaxies and novae, lot of other objects. So the rights, and also in the nature, astronomical objects are one of the best or very beautiful objects. So, okay, as Hubble has shown, they're very, very pretty, not only for science and also they are they are very pleasing to eye. So this study of these cosmic objects corresponds to space exploration. So as you know, human by nature is an explorer. He wants to learn new things, visit new places, and this has forced him to get into astronomy. So what are the major questions plaguing us is whatever we are seeing around us, this what is the origin of this? So that means that what is the origin of the universe? And what are the laws which govern the universe? Are there any laws or they're just random things? And what is going to happen? These three things, whether it universe has a beginning, or what is making universe go, and then will a universe end? These are the major questions asked or we are trying to answer. So this talk, I'll try to concentrate why astronomy and a little bit introduction to astronomical telescopes, and I'll also talk about multi-wavelength astronomy, and then I'll move on to astronomy from space, and I'll end with some of the missions from Indian astronomy, space missions. So here are the 10 biggest discoveries in astronomy. One, we now know that Milky Way is not the only galaxy in the universe. There are hundreds and thousands of galaxies throughout the universe. And we also know that the universe is expanding. It's not stationary, it's not contracting, but it is expanding. And we know how the stars generate this kind of energy. For example, our sun is giving out 10 to the power of 33 ergs per second. How exactly this energy is generated, we know. And we know that there are three main types of stars: main sequence stars, dwarfs, and very, very big stars called giants. And in addition to that, composition of the ordinary matter, exotic objects like gamma ray bursts, neutron stars, black holes, etc. And we now are aware of that microwave background surrounds us everywhere, whichever direction we see. And the new things which we are learning now is something related to dark matter. And we know that planets are not only in our solar system, but there are outside also. As of last count, it was more than 5,500 planets outside solar system are known. And we understand the interiors of sun using neutrinos and helioseismology. Helioseismology is nothing but a study of sun using the vibrations on top surface of the sun. So whatever we study, they are mainly into stars and to a limited extent planets. And the celestial objects can be thought of as stars, galaxies, nebulae, globular clusters, and compact objects like white dwarfs, black holes, and neutron stars, and combining all of these active-galactic nuclei and even binary stars and X-ray binaries. So how do we do this astronomical study? The astronomical study are mainly of 4 ways. Please note that most of the observational astronomy is done in the electromagnetic spectrum. Okay, even though we talk about multi-messenger astronomy, which even consists of particles from outside, like cosmic rays, or we can actually study gravitational waves, but these contributes very, very limited, a fraction of the total information we get through electromagnetic radiation. And then these are carried out from ground-based telescopes. The telescopes are of various ways. Whatever the normally we know optical telescopes. In addition to optical telescopes, we have multitude of other studies. And then space-based observatories. That's a theme of this talk. Why we need space-based observatories. And even we have robotic probes. These are mainly used for in situ studies of planets and maybe our moon. And theoretical calculations and simulations, you want to explain how whatever you are observing. Okay, so this is also this is also done using theoretical calculations. So these are some of the major telescopes around the world. On the left top is a Giant Meter Wave Radio Telescope. This is from NCRA, National Center for Radio Astronomy at Pune, and this observes the sky in radio waves. Low frequency radio waves, and there are almost like 30 of them. Each one is almost like 50 to 60 meters, I think 60 meters in size. And then on the right side is the biggest optical telescope in India. It is in Hanle. It is in Ladakh region. It is actually maintained by Indian Institute of Astrophysics. And then other thing is Mauna Kea and others, where most of the telescopes are set up. Even the 30-meter telescope is going to come very close to some of this place. Okay, after this, space as a platform to pursue science research, it started after World War II. Okay, so the birth of X-ray astronomy by Gicconi, so who actually studied the relativistic astrophysics. Starting of X-ray astronomy program is started with balloon experiments at AFR, and then followed by early Indian satellites. IRS-P3 mission is the first one which actually carried a experiment made from India by TIFR people, and then Solar X-ray Astronomy mission (SOX). This was followed by Lagrangian 2 mission. It's a collaboration between India and Russia. This went on a satellite called Photon and Coronas to study Sun, and now AstroSat. So vantage points in space, we have already talked about 2 vantage points around the Earth. One is the low Earth orbit and the geostationary orbit. In addition to that, we have other points of observations also. For example, these are called as Lagrangian points. So we will take, if people are not aware of what Lagrangian points, we can take up that in the question answer session. So there are totally 5 Lagrangian points in between Sun and Earth. The first one is called as L1. It is between Sun and Earth. So this is a place where our current solar observatory Aditya L1 is placed. And beyond Earth, the point is called as L2 point, Lagrangian 2 point. This is a place which is required where the temperature requirements are very stringent. For example, they want very, very low temperature. For example, JWST is placed here because it observes the cosmos in infrared. So here is a place where we are going to send our exoplanet mission, ExoVerse, in future. So Lagrangian point L1 and L5. So we don't know the use of L3 as of now, because Sun is the higher emitter of very high energy or very high flux electromagnetic spectrum throughout from radio to X-rays. So we cannot actually have any contact with L3, and till now we don't know what may be the use of L3. But L4 and L5 are the most stable points around Sun and Earth system, and these are so stable that many of the asteroids are caught here, and these are called as Trojans. So they are going to be useful in the future because they can actually help in early warning of solar events, solar energetic events. Okay, so after this, the question now we have to ask is, I mentioned about so many ground-based observatories. We have seen a radio observatory and then optical observatory, but then why we have to go to space? You will know very well that it has very, very extreme conditions, both the temperature and vacuum. In the night side, the temperature may drop to almost like -100. Don't quote me on these numbers. This is just an approximate. And in the daytime, it can go up to +100 to +150. So whatever you send, whether it's a satellite or an experiment or whatever it has to withstand these extreme conditions, and at the same time, they will not be constant. They will be repeating. It will go too cold in the night time and the day, and every day or every orbit, this keeps on repeating. So it has to withstand all these cycles. And to make the components and everything to withstand these kind of extreme conditions, so the components will be very, very expensive, and even making the entire satellite or telescope or all the sensors, everything will become very, very expensive. Very, very, very expensive. And also it takes a lot of time. So for example, on the right side, you have Hubble telescope. It took almost 20 years to build. Okay. And then around 2,000 crores was spent on that. Compared to that, similar size optical telescope at Hanley by IAA, we spent only 20 crores. So that is almost 100 times costlier. And then on top of all these things, there is going to be a problem of radiation. So why anybody wants to go to space after all these drawbacks? The reason is, the electromagnetic spectrum, as we know, is a very, very long spectrum. It starts from radio, goes to microwave, and then up via visible, so X-ray and gamma ray. So this is just an example, like illustration of what electromagnetic spectrum is and what is the wavelength corresponds to each of them. So this is again it's an electromagnetic spectrum, but this is how we show. This is how it is shown that what kind of electromagnetic spectrum actually reach ground. For example, you see here. So if you see radio, most part of the radio will reach ground without any problem. But if you come to X-ray and UV, most of that is stopped at a very high altitude. Okay, so you may need rockets or balloons to go just observe this. Even infrared, it will be the same. You have to go higher and higher in the altitude. So a very narrow range of this electromagnetic spectrum, that is the visible spectrum, will reach Earth. So if you want to do any kind of study in anything other than radio and optical, you have no other option than going to space. This is also black body spectrum. We will not worry about that now. Okay. So now, but the question now is, why do we need to actually study any star or any galaxy in any wavelength other than visible? This is a very simple question to ask, right? So the reason for that is the information, whatever we obtain with the optical or in the visible range, is not the only information which is available there. This is a best example of that. You know the picture, whatever I am showing here, the skeleton is the first picture of a person taken in X-ray by Rontgen. So you can clearly see the keys he is carrying also. Okay, so that clearly shows that. So just by going to one more wavelength, we can understand, or we can get much more information than we can obtain with optical alone. When I say optical, it's the visible spectrum alone. So whenever you have some problem with your, say for example, your bones, some problem with the bones, and if the doctor wants to know whether it is broken or not, just by looking at your hand and using optical and naked eye, he can never make out if there is a breakage or not, unless and until it's a compound fracture. Okay, so by just X-raying it, he can clearly see if there is a break, and even if it's a hairpin crack, then he can clearly see that. So that is the reason why you need X-rays. Okay, so that's fine. Again, I'm showing the electromagnetic spectrum, but why multi-wavelength for the stars? So you are all aware of this famous story. You know this story, right? A king asked some 5 blind men or 4 blind men to explain how an elephant looks. So the 4 blind men, they could not actually see the elephant. What they did was they went and touched the elephant, and they explained on the basis of the whatever they were touching. The guy who was touching the trunk, he said that it is like a long, the tail said that is a rope. The guy who was touching the tummy, he said that it's like a wall. And the guy who was touching the different parts, he gave different meaning, the different his way of actually what elephant is. So is it true? No. But are they wrong? No, they are not wrong either. So they could actually guess what an elephant is just by the information, whatever they had. For the person who is touching the tail, it might be like a rope or a snake. Okay. So people will not get a full idea unless and until you combine all these things together. The same way, so you have seen sun. If you go in the early morning or in the late evening, so when the sun is just rising or sun is just sitting, if you see sun, you can see a lot of information more than whatever you can see with the naked eye during the daytime. Please don't do that. Don't tell anybody that I have asked you to look at sun. It is very, very dangerous. Okay. So this is a photo of sun taken by some filter. And it is a visible range. Now, if you see those spots, then you can clearly see that there is something going on, and the temperature, assuming that it's a temperature, then the temperature in those spots are less than the surroundings temperature. So, but on the same thing, if you see with some other wavelength like UV, there's a problem here. So earlier, whatever the spots which were dark, that's why the name spot, now they are bright in the flux. So it's the opposite. And the same thing, if you see in IR, not only they are dark, they are also wide. The whatever that their expand, this one, whatever the area it is covering is also much larger than whatever you can see with normal wave visible. And in X-rays, it gives a completely different structure. So in this way, if you put all of them together, then only you can clearly see. So you remember that electromagnetic spectrum, the first image where I showed black body radiation, the radiation at 6,000 Kelvin and 1 million Kelvin, how they vary. So if you apply the same thing here, so you should be getting dark spots everywhere. But it clearly shows that in the high energy, it is not bright. In the low energy, it is dark. That clearly shows that it is not a black body spectrum. Something else is happening. What is that something else? It is out of scope. It need not be discussed here. But you should just know that just looking at visible won't give you this information. This is about sun. What about the other wavelengths? This is approximate phase of sun and 11-year cycle. So we'll just skip this. So now you see Orion constellation in optical length and optical wave light, and how the same thing looks in X-rays. Okay, this is a very good example of why multi-wavelength observations are required to explain any cosmic source. This is very famous pulsar called Crab pulsar. It is a neutron star rotating very fast, 33 times per second. Can you imagine our sun rotating at 33 times per second? It's one of the most powerful dynamo in the entire universe. This small, almost like 10 kilometer size neutron star, which is rotating at 33 times per second, gives out the energy which is much more than the energy from all other stars, usually 10 to the power 11 to 10 to the power 12 stars combined together. That's the kind of energy this small one is giving because of rotation. Okay, but this is not seen in optical on the right, or even in infrared. Only if you go to radio, X-ray, then you will realize that it looks like a top, spinning top. Okay, and even our entire universe looks completely different in different wavelengths. So hence, it is required for a not complete, better understanding of universe or cosmos. We need multi-wavelength observations. So this I have already spoken. Fine. I understand that X-rays or UV do not reach Earth, so we are forced to go to space. Then why Hubble, which is supposed to be working in optical, is sent to space, spending the 100 crores, 100 times more money, and also spending so many years? The reason is two things. So this is just one example how the best telescope on Earth can actually photograph a nebula, and the same photographed by butterfly nebula is photographed by Hubble. You can see the difference, the kind of information you get. Why it's so? The reason is we call it as, all of you are aware of this very famous song, no? Twinkle, Twinkle, Little Star. Actually, this Twinkle, Twinkle, Little Star is like an enemy for astronomers. So what happens is, this twinkling is because of atmospheric seeing. So this atmosphere, it's not static. So it will be turbulent. It will be moving. So this motion actually moves the light photons such that they will not fall on a single point. They will be forced to dance around. So this gives a blurring of the image. So this blurriness is not, we cannot actually get back the original image from the blurring. This is not completely true. There are ways to achieve this, but that is not completely successful. Okay, this is one way. The second way is attenuation. So I told you that you can see the sun in the morning and in the evening, but not in the daytime because it can burn your eye. The reason why you are able to see sun in the evening or morning time is because sun rays will be coming almost horizontally. That means that they will be coming through a larger mass of atmosphere, a larger atmosphere, and hence lot of light is actually absorbed by the Earth's atmosphere. We call it as attenuation. So in this way, light coming from outside also, it gets absorbed. So more than 70%, many times it more than 70% of the light will get absorbed. So we will not get the enough. We cannot observe fainter objects because of this attenuation. By going away means going out of Earth's atmosphere, we can solve both this attenuation and atmospheric seeing. Because of this, even optical observations are benefited by going out of Earth's atmosphere. Okay, so now coming to major international missions, which space missions. So this is a famous four called Hubble, Compton Gamma Ray Observatory, Chandra. Chandra is named after Indian scientist Subramanian Chandrasekhar. It works in X-rays. This is a exospectrometer. Spitzer is in high infrared, XMM Newton again in X-rays, and AstroSat is India's first dedicated astronomy mission. And out of this, most of these are multi-wavelength, and out of them X-ray, out of them X-ray in X-ray, Rontgen X-ray Timing Explorer RXTE, Integral works in gamma rays, Swift works in mainly X-ray, but it is, as the name suggests, it is capable of moving to a target very fast. This is mostly useful for studying transient objects. Transients means the ones which vary in time fast. Then AstroSat. So solar missions, we have in addition to SOHO and Hinode, our Aditya L1, which is sitting at Lagrangian 1 point and doing continuously observing sun. And planetary missions from India itself, we have Mars Orbiter mission, Venus mission is planned, and Chandrayaan is 1, 2, 3 has been already sent. And deep space missions, Galileo, Voyager 1 and 2 are from NASA. These are just a sample. These are all not all the satellites. Okay, Galileo left, Voyager left our Earth almost 40 plus years now. We say it has just crossed our solar system. So some of the major requirements of any space mission is the sensitivity of the instrument should be very, very high, and instrument stability. And instrument, not only instrument stability, instrument platform stability is also very highly required with highly accurate modern sensors. And deep space missions, the fuel efficiency, because you can't carry infinite amount of fuel with you, and hence it has to, they either have to be fuel efficient or you have to go for alternative ways like gravity assist, electric propulsion, etc. And as I mentioned already, extreme environments. So when I'm talking about stability, instrument pointing or platform stability, so they have to be stable in the order of arc seconds per hour. So if you hold your gun, for example, recently when you saw that, okay, whatever our shooters were, when they won bronze, their accuracy was in minutes, arc minutes, but we are talking about 3,600 times better than that. Okay. So these are NASA's 4 great observatories, and JWST has been added to one of them. JWST, I call it as an engineering marvel because of the technologies included in that one, and the kind of amount, the kind of effort which was put in to keep that in that kind of temperature and etc. I can give almost 4 hours lecture on just on the technologies which are involved in JWST alone. And all of this is giving fantastic results. We are already proving or disproving many of the theories, and we are even finding that some of the results obtained by Hubble cannot be explained with the data obtained from JWST. So Hubble Space Telescope is the one which changed the entire world, and it so this if you ask any student, I'm sure that he would have come across 1 or 2 images of Hubble Space Telescope taken by Hubble Space Telescope, and he would have heard HST. So these are some of the images taken by HST, but this is a one which is very close to my heart. So each of these dots, if you can see the dots, these dots are not stars. Each of those dots are an individual galaxy. Can you imagine this small space? This is only few arc minutes by few arc minutes. That is almost like 1/10 of our moon has more than 10,000 galaxies in this small area of the sky. Okay, and JWST, when it attempts a similar image, then we are expecting the numbers to go up by at least another factor of 2. That is 100 times more than this. So this is a kind of stability. This is a kind of signs we are expecting from going outside solar system. Sorry, outside Earth. So that is fine. For cosmos, you have to go outside because they have the atmospheric attenuation and everything. Then why study Moon and Mars? So this studying of other planets, for example, Venus, which is very similar to our Earth, but at the same time is having extreme temperature, almost like 200 or 300 degrees centigrade, and extreme pressure, 100 times more than Earth. Okay, when two planets started together, why one planet turned out to be such an extreme, why it became Earth has present pressure and atmosphere. To study that, by studying Venus, we can actually identify, find out why Venus became like that, how we can stop or how we can avoid Earth becoming like that in future. So this is one of the reasons why we need to study other planets. And tomorrow, for some reason, if we have to leave our Mother Earth, then where else to go and stay? So that also you can't. If tomorrow, if you are forced to leave Earth tomorrow, you can't start building a rocket today. So that's why you have to work in between and you have to prepare in advance. So that's why we are going to study other planets and studying Moon also helps us in understanding how Earth itself came into existence. Okay. Now coming to Indian Space Science Program, I think I have 5 more minutes. I'll try to rush up. Currently, India has 3 launch vehicles, PSLV, GSLV, and one more called LVM-3. So ISRO Space Science and Exploration, in astronomy, we started with Indian X-ray astronomy payload in 1996, followed by launch of AstroSat 2015. AstroSat will be completing 10 years next year, and even though it is designed for 5 years, it is working well and it is giving fantastic results. Just last week, there was a discovery of a new blue straggler star with AstroSat, and we expect it to survive for at least a couple of years more. This is followed by India's first mission to study X-ray polarization from cosmic objects, and Aditya 11 you are all aware of. This is to study Sun from Lagrangian 1 point. Coming to planetary exploration, it started in 2008 with Chandrayaan-1. Chandrayaan-1 detected water. You are all aware of that. So this discovery of water actually rebooted entire lunar program of Americans. So you all know that America went to Moon and they took they put man on the Moon almost 60 years back, and after that suddenly they stopped. Okay, for last 50 years they have not attempted to go to Moon. So, but after the results from Chandrayaan-1, they started entire new programs. Now they want to put woman on Moon, maybe in this decade. So then Chandrayaan-2 confirmed this, and Chandrayaan-2 is giving the highest resolution images of Moon. Even though it was launched in 2019 and completed 5 years, it is still working very fine, and it is giving lot of results. And I forgot to put here Chandrayaan-3. Chandrayaan-3, all of you are aware of that. We could actually successfully demonstrate soft landing onto Moon. And some of the future missions which are under consideration are exoverts. This is to study exoplanets, planets outside our solar system. And another one is to study gravitational wave events. And one of the best UV imaging spectrometer is going to be in INSIST. And we are also planning to land on Mars. And we are going to Venus to study the atmosphere of Venus. So these are the current AstroSat. I have already mentioned AstroSat, so I'll come back to this if time permits. And these are it carries 5 payloads, so all these things we can study. And Chandrayaan-2 is a planetary mission, and I'll almost stop here. This is Chandrayaan-3. So this is called as Shiv Shakti, the place where we landed there, and we landed there on August 23rd. So our Honorable Prime Minister has talked about celebrating this day throughout India as the National Space Day, and I'm sure this talk is under that National Space Day. Now you know why it is National Space Day. I didn't put an image here. This is an image of our Shiv Shakti point where our Chandrayaan-3 is landed, and taken from the rover from a farther distance. So there is a boulder. We lovingly call that as Nandi. So Aditya L1 was launched in 2024 January, and this is to study sun, and it is launched at L1 point. I'm really sorry, it is a large kept at L1 point. So this is how it is going to be studied. This is the mission to study exoplanets. So it is very tough to study exoplanets because they will be very close to the parent star, host star. So they are going to use a technique called transit method. So assume a planet is transiting or going in front of the star. So when the planet is in front of the star, but if you do some observations, the observations will be the sum of the planet and the star. So when the planet is behind the star, then the observations will be only from the star. If you subtract the two, then you will get the effect of planet alone. With this, they plan to study the atmosphere. Okay, so this is the transit method. This is going to this is under study. So just before closing my talk, I'll just mention about some special missions. As I mentioned, Voyager was launched in 1977. It is almost covered very close to 1 day, 1 light day. And this is the first man-made object to leave our solar system. And to study asteroids and moons, there are multiple missions planned. Psyche is the one which is going to study the most metal-rich asteroid. And now Apophis, which is going to come very close to Earth within our geosynchronous orbit. We are expecting the asteroid to pass within 30,000 kilometers of Earth. So even ISRO is planning for a mission to go, maybe fly by it, just go around Apophis, or we might even try to land on Apophis. And there are multiple other missions, Europa, Clipper, Dragonfly, etc. This experiment, I want to talk about ISS, International Space Station. You are now all aware of the problem which is faced by ISS now. So one of our Indian origin astronaut is stuck on ISS, and the people are struggling to bring her back. Okay, other than that, ISS is doing fantastic job. And one of the experiments which were done on ISS was what is called a Skelly experiment. This is very, very interesting experiment. So on the top, the picture, whatever the two people you are seeing, they are identical twins. So one of them was sent to ISS, and another one was actually on ground. So both of them carried out exactly same type of workout, same types of food and everything for more than 1 year. And after 1 year, both of them were compared how they were. Okay, so that gave a lot of information about the effects of staying longer in the space, or what benefits and what kind of problems you may face by going to space. Okay, in addition to that, we are also working on how we can grow food in the microgravity experiment and others. So Artemis, I have mentioned about Artemis by US. This is a completely new lunar program came up because thanks to Chandrayaan-1. Okay, so I started with this image. We at the astronomy started to understand how, from where all this light is coming from. We are still yet to figure out where exactly they are coming from. And thank you for your attention. Thanks a lot. Manish? Manish, thanks for this question. It is very close to my heart also. So I did my studies till 7th standard in Kannada medium. Okay. After that, I went to a government high school, and after that, even the college and MSc, during everything, it's a government one. Okay. I never studied in a private college or private institute. Even my PhD is from Indian Institute of Science. So everything either operated by government or government aided. Okay. I'll put another one. The maximum fees I ever paid in my whole life is 105 rupees as a joining this one for 8th standard. That's the maximum, highest money I ever paid. Okay. And I was never a rank student. So first rank was always to somebody. I was in the second or maximum third. Okay. So that doesn't make you like not suitable for becoming an astronomer or astronaut. Then coming to the question cosmonaut, it is very tough to say because the number of chances for a cosmonaut is very minimal. Just to give an idea, whoever is already selected, the 4 people already they're undergoing training, even they are not going to go into space. Only 1 or 2 out of the 4 will go to space. So that's the kind of competition which is there to become a cosmonaut. So we cannot actually say that this is a one course you have to take to become a cosmonaut. It's not possible like that. Okay, but I suggest that you do some engineering or basic sciences where you can actually be on the way to the cosmonaut. That's all I can say. I can't pinpoint saying that if you take this one, then this particular course, then you are sure to go become a cosmonaut. It's not there. Mars is very close to Earth as of now. For example, the day of Moon and Mars and Earth are very close, 24 hours and 23 point some days. And Mars also has seasons. Okay, and on top of that, Mars is very, in other terms also, Mars is very close to Earth, and there is a possibility of having water on Mars is very high, and people even assume that there was water at least at some point. So because of and nearest, okay, because of all these things, Mars may be our best bet. Compared to that, if you take Mercury, then Mercury the temperatures are very high. The daytime temperature is almost like more than 500 Kelvin, and the nighttime is almost like minus 200. Unless and until you keep on running, so it will be almost impossible to survive on that. Venus, I have already mentioned that it is very like temperature is very high and the pressure is also very high. And beyond that, we do not have any planet which has a solid surface. So our best bet is Mars as of now with our current. Okay. So whatever the programming language you say, I can actually find at least a place where that language is used. For example, for my astronomy, I use anywhere from C, Fortran, Perl, and Python. And for anything like making the UI and others, people use JavaScript. Web-based things, JavaScript is used, and some of the places even Rust is used. So you just mention, and if you come to actually hardware, there is VHDL, which is always again on C or Fortran. So you just mention one language. I'll show you where it is used. Okay, it's a very nice, good question. Thank you for asking. So what is happening is the places where where these parts are appearing, there seems to be some magnetic fields. Okay, these magnetic fields suppress the temperature, not very much. It's only a few hundred degrees centigrade less. For example, if the surface is around 6,000, this will be around 5,500 to 5,600. Only few hundred Kelvin or few hundred degrees less. But you know that the flux by any black body goes as t to the power of 4. So when this 0.9 pi into 0.9 into 0.9 into 0.9 compared to 1 into 1 is very small. It looks much smaller, less. So that's why they look darker. Okay, and this is the main reason for this is the magnetic fields. You can read about the magnetic field, how they come and go, even the flares, everything because of the magnetic fields. Okay. Mhm. Uh, Let me say that ISRO needs people from almost all strata of all faculty. So not only from engineering background or science background, we even need from commerce background or maybe even a computer science background and everything. But the opportunities will be limited for the other fields. Okay, so ISRO will be actually calling for recruitment very often. For example, one for BTech is going on now also. So at least once or twice a year, we'll be calling for recruitment and mostly for engineering people. And BSc Computers and MCA or MSc, it will be as need basis. Okay, as and when it is required, we'll call for this one people. Oh, that's good. So NASA is actually trying to do one such thing because you will permanently be away from the Earth's atmosphere, and also it will be very very stable. And they were planning to do something. For example, they are trying to set up a one liquid mirror telescope there, because when the liquid that is mirror is rotating to make the liquid in a mirror form. Okay, the vibrations are almost not there on Moon, so they can make very very large mirror with that. That's one proposal is already there. Like that, many other people wants to put something or the other there. But the one problem there might be micrometeorites and others. They have to make sure that okay, something like that will not affect their optics. As of now, we have not actually started work towards that. There are a few proposals in the anvil, so we might take up maybe next decade. So the deepest what we are thinking of as now is Venus, and maybe Venus is the maximum we are thinking, or the project which is almost like in the study phase. Even myself is working on that. Okay, so the AstroSat gives fantastic data from black holes, binaries, and others. There are multiple groups which are involved in studying of these black holes. Since you asked particularly about ISRO, so we have multiple places. We have scientists who are working on that. One place is URO Satellite Center. It's in Bangalore, and Physical Research Laboratory in Ahmedabad, and Space Physics Laboratory. These are some. There are few groups who are working on this. Other than this, almost all the astronomy research institutes in India are some one way or the other are working on black hole astrophysics, theoretically and observationally. Okay, even though I'm saying that expansion, the expansion is very very slow. So I'll just give you some other answer. Okay, so we are all talking now, sitting in front of the computer and everything, assuming that we are almost like stationary. But if I say that we are moving at 35 kilometers per second now, can you believe that? Our Earth is moving almost 35. Manish might actually correct the exact, give the exact number, but approximately around 35 kilometers per second we are moving now. But we do not see that effect because it is not accelerating. It is only just velocity, just speed. So wherever there is no acceleration, it is very difficult to actually gauge that, because it will for all practical purposes, we will see that it is like stationary. Exactly like that, the amount of expansion which is happening is so slow that within our lifetime, it is almost impossible to perceive any change at all. That's one of the reasons why we will not have any effect on that. Then another thing is the universe is not expanding, and we don't know where exactly the universe started expanding. It is expanding for each of them is moving away from each other. Okay, it's not like that Earth is at the center and everything is moving away. So hence, so we will see something. No, everything is moving away from each other. So one easy way for people, scientists trying to explain that is, you take a balloon and put some 3-4 dots on that. When you actually blow the balloon, each point, there is no central point. Every point is moving away from each other. So there is no preferential point where that will be stationary and all the others will be moving away. So in that way, it will be impossible to find out where the center is, and hence it is almost looks like isotropic. Astronomy is one field where I am paid to follow my hobby. Okay, so in that way, that means the one which keeps pushing me to understand or to explore many unknowns. One of the reasons why I choose astronomy, because I will not know what I'll be doing tomorrow or day after tomorrow. If I become a clerk, I can clearly write in my diary saying that, okay, in the morning I'll sign, in the afternoon I'll do some tabulation, and the evening I'll do this one. And that will not change tomorrow, 1 week, and even after 1 year, it will be the same. But as a scientist, the unexpected is the one thing which you love, the one thing which you cannot actually guess. So I'm doing something new. That's what keeps pushing most of the scientists. Not only me, most of the scientists are actually pushed because of that unknown thing, or this one of achieving something which are not achieved by others. I can't say exposite is directly studying black holes, because the polarization comes from either magnetic field or from the scattering or something. So since you are very well aware of that, black holes do not allow anything to escape. So the light coming from black holes need not give you any polarization. Okay, but so if it is a binary, as and when the matter is falling closer and closer to black hole, when they are very close, the matter will be undergoing extreme conditions. Temperatures might be of million Kelvin, and there will be scattering from the other one, reflection from the other layers, and etc. All these things can contribute to polarization. In that way, we can study X-ray polarization of black holes also. Start reading. So that's one of the easiest ways. And start if you're in a high school, you can actually start reading popular articles, and you will be, nowadays you have lot of access to information around thanks to internet. So look into some of the major results, whichever even the newspapers will nowadays publishes major results. For example, yesterday there was a gamma ray burst detected. Once you read something like that, you try to understand what is gamma ray burst and why that good, why it is important, what is so special about it. Like that, you start with one simple article and start going through that references given then, and in the references given there. So then you will you may come across one particular topic which you would like to continue further or specialize in. To be frank, I'm not an expert on that. In very simple terms, what dark matter is says is, now you know from Kepler's laws, all the particles at a distance will be following certain rule. The period will be related to the distance, etc., and mass. Now, if you take a galaxy and you plot all the motions of all the stars, they have to you expect them to follow one particular pattern. So now, in certain galaxies, it was found that after certain distance, they were deviating. So this deviation cannot be explained by the observable stars and their masses if you sum them together, put them together. So then they started coming up with something which you cannot observe, means it is not emitting any light at all. It is almost like a kg of mass kept, sorry, kg is very, very small. Some mass is kept there, which is at very close to 0 degree Kelvin. So it is not giving out any energy information, but as a mass, it's there. Since mass is there, gravity is also there, and the gravity is making it go flatter. So this is the first time how somebody postulated what dark matter might be. And now people are actually studying them and finding out what should be the amount, and then calculated, and to their astonishment, they found that actually whatever is here you see is less than whatever you don't see. So that's what is called as dark matter. Dark energy, to be frank, I'm not an expert and I don't want to comment on that. Okay, I'll go. I'll tell you in general, but don't take that this is like a gospel and this is the only way. Okay, in general, if you are in any field, either mathematics or engineering or chemistry, even chemistry or biology, we are looking for people who are top in that. Not exactly top means you are need not be 99%. You should know the subject and you should be ready to put in effort. See, for example, why I'm saying biology means we are now working towards astrobiology, and we are working on going to be working on India's space station. Okay, so there we will be doing a lot of experiments with biology, and so we will be needing that. And whenever we are talking about new material for actually launching rockets and everything, we need chemistry there. Metallurgy is required to make sure that okay, whatever material we are using, metals and others we are using for the rocket is required. Metallurgy is required. Civil to make sure that okay, whatever the there's some pressure which is exerted and the temperature which comes out when a rocket is launched, and other things civil is required. Like this, and mathematics to find out the orbits and orbital mechanisms, calculations, everything. So like this, we are looking for people almost in all faculty. So if anybody comes and say that I'm studying in this one, can I join? Yes, you can join, but with a certain criteria. So you have to some of the criteria which is very common for any job with this one. So you don't worry about any particular field. So you need not get into aeronomy or astronomy in particular to actually get into ISRO. Any field is okay, including administration. We also need administration to take care of all these people. Okay, and even some commerce is required. So because unless and until you have salaries, whatever said and done, you can't actually continue to work without salaries. So lot of things are there. So we need almost in each and every field we need people. And to get into ISRO, one of the easiest way is after 12th, because many people are asking after 12th. One of the easiest way is to get into Indian Institute of Space Technology. Manish can actually tell you how exactly it is. So once you get through that one, it's almost like you have 50% chance of getting into ISRO if you excel in your studies. Okay, that's one of the easiest ways. Otherwise, anyway, it's very common. We announce we advertise the position, we solicit this one applications, and we have a nominal cutoff, and after that shortlisting, they have to undergo some written exam. After the written exam, again we have interview, and after the interview we make the selection. This is very common, and I think it is common for everybody. So there, what we look is how much you know, how much you understand, how much you are ready to learn. Thank you. Thank you. Thank you very much.